Good morning. All right. Last thing we're going to do here this week is 10.4. So let me get something back in my office so nobody should interrupt me like a 22-year-old son with a potty mouth. Sorry about that last night. All right. We're going to graph. 10.4 is kind of like, how would I put it? We got a lot of stuff that they threw in there. It's like, oh, I think I'll put this in 10.4, and I'll put this in 10.4. A lot of little things that add all up. And although it does relate to what we've done so far, there's no direct correlation. Okay, so we were graphing parabolas, graphing parabolas, graphing parabolas. Now, all of a sudden, we're going to graph something like this. Still a function, but it's a square root. There's no formula to put it into and find the vertex and all that kind of stuff. When you have a square root, what you need to realize is that it's going to start somewhere and then get really big really quick. Or start somewhere and get really small really quick. Okay? And the only way that you can best do this is you pick numbers for x and solve for y, because remember, that's the same as y. So if I made x 1, I'd have 2 times the square root of 1, which is 2 times 1, which is 2. Now, I don't want to make x 2 because I don't know what the square root of 2 is. I don't want to make x 3. I don't know what the square root of 3 is. But I can make x 4. I get 2 times the square root of 4, which is 2 times 2, which is 4. Now, what's the next number that would make sense to put in for x? 9. Because then you get 2 times 3, which is 6. Okay? Now, let's graph these numbers. And I'm sorry, but this stuff's going to get in the way here, but that's okay. All right, when x is 1, y is 2. When x is 4, y is 4. When x is 9, y is 6. See how it's getting bigger? And one other number we need to put in there is 0. Let's say when x is 0, you get 2 times the square root of 0, which is 2 times 0, which is 0. Okay, so you also have this point. That's where it starts. X can never be a negative number. You can't put a negative number in a square root. Okay, so it starts here. Oops, and I can't draw on this. And it gets bigger and bigger and bigger really quick. Okay? So when you have something with a square root, make a chart. Pick numbers that make sense, that come out to be whole, and graph. Okay? All right. They also want you to know something about symmetry. Okay? They want to know symmetry in respect to the x-axis, the y-axis, and the origin. Origin being this point right here, where x is 0 and y is 0. Okay? Symmetric being, do you have, if it's symmetric to the x-axis, if you have a point here, you have a point here. If you have a point here, you have a point here. There's symmetry. Symmetric or symmetric to the y-axis means if you have a point here, you'd have a point here. If you have a point here, you'd have a point here. Symmetric. And symmetric to the origin means it's symmetric to both the y-axis and the x-axis. Okay? And there is a test. When they say, is something symmetric, there is a test. Okay? If you want to check if it's symmetric to the x-axis, you replace y with negative y, and then is it the same still? If it's the same, it's symmetric to the x-axis. For the y-axis, you replace x with negative x, and then ask, is it the same? Okay? And if it is, then it's symmetric to the y-axis. And the origin, it has to be both x and y symmetric. Okay? So, with that said, let's look at y equals x squared plus 4. Okay. Is it symmetric with the y-axis? With the y-axis, we would replace x with negative x. Well, what is negative x times negative x? Positive x squared. So we're back to what we started from if we replace it. So is it the same? Yes. Now what about the x-axis? That's where we take exactly the, that's just a y, where we take it exactly the way it is. We replace it with a negative y. Now there's nothing we can do to simplify. Is it the same? No. It's symmetric to the y-axis. It's not symmetric to the x-axis. And because it's not both, then it's not symmetric to the origin. Okay? All right, let's look at another one. What if I had x equals the absolute value of y? All right, y-axis, that means I replace this. Can you simplify or do anything? Or just look at it this way. Will the absolute value of anything ever become a negative number? No. The answer is no. All right, x-axis. What if I said, that's where you change the y, equals. Okay, regardless if this is negative or positive, will that work? In other words, is that the same? Yes, it is. So is it symmetric to the x-axis? Yes, it is. Is it symmetric to the origin? No, because it's not symmetric to both. Okay? All right. What else do they want? Oh, they want you to understand increasing and decreasing. Increasing and decreasing. Okay? They just want you to understand where things increase, decrease, or stay the same. Okay? Now, what I mean by that, let me draw something here. Okay. Okay, now you read a graph from left to right. So, coming this way, this graph is increasing, and then it stays the same. It doesn't increase or decrease anymore. So, we would read this as it's increasing from negative infinity to what? It's always on the x-axis. To 2, including 2. And then it stays the same from 2 to positive infinity. I want you to explain it, to read it. Okay? Let's look at another one. What if I had this picture? All right. Reading from left to right. What is it doing? Coming up, it's coming up, it's coming up. So it's increasing from negative infinity to what? -4. Then it goes down, 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 down. So it's decreasing from -4 to what? -1. Then it goes back up, 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 up. So it's increasing from -1 to positive infinity. Just reading it. That's all. All right, let me show you one more. And it doesn't have to be a dramatic increase or decrease. It could be something very fluid. What I mean by that is it could look like this. Okay? Now, stop and think. From left to right, what's it doing? It's going up. So it's increasing from negative infinity to -1. Because we're on the x-axis, does it right there. Then it's decreasing from -1 to positive infinity. Okay, so it's not what I meant by it doesn't have to be a V. You know, it could be fluid. And you just have the top, like in a parabola. Okay, so you're just reading graphs. Where is it increasing? Where is it decreasing? And where is it staying the same? Okay, that's 10.4. All right, you guys have a good week, and let me know if you need any help. That's what I'm here for. All right, bye-bye.